back. We're live at the 1 o'clock rock. Okay, this is the 1 o'clock rock in the form of research in Manoa, which we love to do this show. It's all about HIGP, really, you know it is that. That's Jeff Taylor on the far side agreeing with me.
Everything is about HIGP.
There it is. You heard it here on Think Tech. And Linda Martell, also HIGP.
Yes.
Welcome to the show, you guys. Nice to have you here.
Thank you,
It's
Jay.
good to be back.
Yeah, good to be back. Where have you been?
We've been around, including we went to Houston, Texas.
Yeah? What was
And
there?
they correctly do not claim to be a paradise.
Who but Hawaii could?
So we just came back from the Lunar and Planetary Science Conference, the 47th Lunar and Planetary
Wow.
Science Conference. It started actually as the Lunar Science Conference a few months, half a year after Apollo 11 returned from the moon with its load of samples.
And that was an
was the
important
first
event
one.
to
Oh.
generate the conference, yeah?
Yeah, it generated it, and then they kept having lunar science conferences, but it got bigger and bigger, and the moon relating to other things, and so it became the Lunar and Planetary Science Conference after about 8 years, and that's what it is now. And so this was the 47th conference, and I went
How
to
many?
all but 2.
Is that right?
Yeah,
That's
but
amazing.
there are some people who have been. There's only 6 now who have been to all 47.
Did you get a medal or something? I bet you
No,
do.
but you get, he gets to say it.
Bragging rights. That's
Bragging rights are good.
We met students so that it was their first conference, and everyone from that person that's been to every one of them to the new student, that everybody's excited about this.
Yeah, sure.
Yeah.
It's still important. It's still as vital, as vibrant as ever. There's more things to know and find out. So tell us about academic conference. It's not academic is probably not the right word for it. It's a science conference.
It's a
right?
science conference, and not everybody is even associated with the university. Some are with, there are private nonprofits that raise enough money to do research, and then there's the labs, the NASA centers, Jet Propulsion Laboratory, they have big research arms, Smithsonian, and other organizations like that. So
Industry, government, and academia,
Yeah.
all of those things.
all together,
And
yeah.
how about interested guys? How about schmoes like me? Could I go and sign up and walk around and meet people like you?
You can, yes.
that is
Everyone
something.
is, and we do, and we have the press come too, the science press in particular, who cover it and look for new ideas.
here's
In fact, here's
This is an
this
example
picture
of
is
what we have here.
of the poster session one night, and this is actually kind of early in the evening, and it gets much more crowded than it appears there. There's both posters where it's like a little science fair.
Yeah.
And everyone has elaborately printed posters nowadays because we know how to do
Scientists make posters just like kids do.
that. Yeah. And there's me.
All scientists are kids anyway. You know what I mean, Jeff?
Yeah, oh.
You know what I mean?
Oh,
Well, that's
you should see
exactly
these
right.
people. Yeah.
So there were like 1,700 scientists this year.
Yeah.
Oh, that's
This, by the
great.
way, is me holding a moon sample that's in a container, so it's protected with, this is an interesting story about taking care of the lunar samples. You know, they've been back for 47 years, and that is Andrea Mosey, who has been working in the Lunar Take Care of the Rocks lab for all those years.
Wow.
And there are a few others who have been there as long as her, but now they're adding younger people, and so there's a whole full age range, so that they teach them all the expertise they learn. Because you know what, if you take a sample of a moon rock, this is now true of the meteorites that we have from Antarctica that they curate. They take a picture of the rock, they chip a little sample off after it being carefully selected, often by the person who's going to work on them.
Yeah.
And then they take a picture again. They weigh all the stuff so that they really account for all the masses.
All the material in the rock.
Yeah, and people like Andrea that we were showing there really know how to do this. I mean, it's
Like cutting diamonds.
yeah, it is, and
Cut it
it's
the right way.
yeah, except these are more valuable.
Sorry.
Those moon rocks started the whole conference, but it's wouldn't you say they're sort of still the star because we're still doing research on these
Yeah,
rocks with
and-
new instruments, and we have new questions about
Yeah.
the rocks.
It is amazing.
Sometimes you want to go back and look again,
Yeah, yes, you do. And we get the new tools that have come along just have made the rocks just a gift that keeps on giving. We just learn better and better ways to find out what those gifts are because we can analyze things so much better.
So if I'm Jeff Taylor and I contact the woman who is the sacred keeper, the keeper of the sacred rocks, so to speak, will I have to go visit her? Will she just send it to me? It's like a museum piece on loan or something.
It also isn't just her. She's the one who processes the sample, but there is a curator. Current one is named Ryan Ziegler, and there's a committee.
Oh my goodness.
Hey, it's the government.
It's pretty
and it's a committee that I happen to be on, and have been on in the past too, called the Lunar Allocation Subcommittee of CAPTEM. CAPTEM, of course, the acronym is NASA, and that stands for the Curation Analysis Planning Team for Extraterrestrial Materials. And anyway, so this committee, though, the Lunar Allocation Committee, meets twice a year to discuss requests from scientists. And it's kind of an interesting thing to be on because the idea is not, in contrast to proposals, when you review proposals, people are always nitpicking, finding fault, whereas this one is, you might find it's not finding fault, you're finding, well, that sample they're asking for is not quite right for their purpose, because this committee consists of people who really know them.
Been there anyway, right?
Know the collection.
Yeah.
And so
they might say no then.
So sometimes you say no because they actually did not demonstrate that they're going to make good use of the sample. It doesn't happen often, but you do say no. And then, but mostly it is saying how many samples at first to see how it goes, and which samples. That really is a very important thing, and you have to have enough people on the committee who have worked with them for decades and decades.
They have to slip into the skin of the guy who is going to look at the sample and see what his science is like and whether it's a realistic expectation on his part.
Yes. And because we don't want to waste the samples, there are guidelines. It takes exceptionally important reason to get a sample whose weight is equal to, we don't want to go below 50% of the original mass. At some point you have to, but in some of the rocks it's going to take another 100 years probably to do that. But others, some important rocks are only this big, an inch across. And sometimes
a few grains.
There's less than half left of some of those. And so
does it come back? Does the sample come back?
It depends what they do with it. For example, we got a quarter of a pound of moon dirt altogether in 110 1-gram samples, and we sieved them, and then we did this X-ray measurement on them, and all that will go back and is still very useful for other purposes. Some experiments dissolve the sample, so it doesn't come back.
The end of the story.
Yeah. So it depends on what the analysis is. And another interesting thing, we allocate samples that are return samples, they call them. I mean, not returned from the moon, they were that, but also a sample someone worked in the lab and sent it back. And some of those have had some things done to them, even heated to 100 degrees or something Celsius, but they are still valuable for some other purposes.
You can figure out.
That goes back into the return from vault, and these are vaults too.
And that's in Houston?
In Houston, yeah.
Here's a sample.
Oh, now that sample, this is very cool. This is the vial that I worked with a guy named Klaus Kyle for many years, who just retired a couple of years ago from HIGP, UH Manoa, and this is the first sample they got from the Apollo 11 mission. And I just happen to have the vial here in my pocket. There you go. Always carry a bit of the moon in my pocket. Here it is. There's no. It looks like there's dirt inside, but really it's coating the side.
Can I touch it?
Yeah, it's just coating the bottle of the very fine, finest grains.
Powder.
Yeah, it's a. Oh yeah, don't shake it. Whatever you do. But it's
irreplaceable.
It's cool. I just like it. It's an artifact, of this first mission.
Yeah.
And so they kept this. In fact, here's a fun story. The guy, Klaus Kyle, if we could look at the picture that followed this vial, That's an awful word, isn't it? This vial container.
We have a picture
Oh,
of
see
Klaus.
that? That's
There's
Klaus. I was taking
I
relative.
know Klaus.
Yeah,
I'll
taken-
tell you, Klaus was at the astronomy conference here
Oh, yeah.
at the convention center within the last 6 months. Is that
Yeah.
logical to assume that? I think I talked to him. Yeah.
Yeah. Anyway, see that thing he's holding? That is a invention he and an engineer made called the energy dispersive system spectrometer. And it measures, it's on, see the gizmo in the background is our electron microprobe. That is, they all have these kind of things on it. They never had it before. And he invented it back in the 60s when he was at NASA Ames Research Center. And it's neat. These are all, they're routinely used now. And this was the first one that he had made. And it kind of shows he felt right at home when he moved to SOS to HIGP, because that's one of the things we do is make instruments. You know, we made them back in the old days for telescopes on Mauna Kea to attach to them for spacecraft and attachments to our laboratory equipment even like this one is. So it's really very
What does that do?
neat.
That
It shoots out an electron. Well, actually, the instrument itself shoots out an electron. This just counts them in different energies, and that tells you the elements they're coming from, and you can get at least a qualitative assessment of how much. Like this mineral has more iron than this other one, and so you can really you can kind of map a whole.
So it could look at that sample you just showed me.
Yeah, more likely it looks at a little polished piece of rock.
Okay, but it's
But
a
you
little
can-
sample. It fits inside.
Fits
that
in.
thing?
Oh yeah, yeah. They're small samples. Yeah.
Interesting. Got some more pictures? Let's see what we got. All right. So give us a running description.
Yeah.
Well, first off, that title of this talk is interesting because it's so nerd speak. But see the numbers 72415 and
Yeah.
76535.
Yeah.
So those are Apollo 17 samples collected by that astronaut in the background picture. You see the man bouncing
Very
around?
person. Yeah.
Harrison H. Schmitt. So he was the only geologist astronaut in the Apollo program, Apollo 17 astronaut. And he was at the conference last week giving a talk about his work on these rocks that he collected.
Using things he learned doing his PhD dissertation, and that is his nickname is Jack Schmitt, named after his uncle, I think, with two models that were doing a fashion shoot down
Oh,
at the
gee, I
conference.
wonder who they might be.
Yeah.
Nice clothes. Gee, why do I feel there's a sense of similarity here? Why do I feel we need to take a break? That's Jeff Taylor and Linda Martell
Aloha.
of HIGP.
My name is-
We're talking about Friends and Discoveries at the Lunar and Planetary Science Conference just happened in Houston, Texas. We'll be right back.
Hi, my name is Stan Osserman, and I host the show every Friday here on Think Tech Hawaii called Stan the Energy Man. We talk about everything energy, from anaerobic digesters to batteries to hydrogen fuel cell and grid power. And we do that to keep you informed on the latest technology that's out there and the things that are going on in Hawaii. We broadcast every Friday from noon until 1 o'clock, and I hope you'll tune in. So sometimes we'll be on Think Tech, and sometimes we'll be on Olelo Channel 54, and I'd like you to listen in to me and join me every Friday. We'll see you then. Aloha.
Hi, I'm Ethan Allen, host of Likeable Science on Think Tech Hawaii. Come join us every Friday at 2 p.m. when I interview interesting scientists about what they do, why they do it, and why we should all care about it. It's a lot of fun to see. We hear, and you can learn interesting stuff. You'll hear all kinds of fascinating science, and we know you'll have a great time. Hope to see you then. Bye-bye.
Oh.
Okay, we're back. We're live. We're talking about friends, actually. Jeff Taylor and Linda Martell of HIGP in SOWEST here at UH Manoa on research in UH Manoa. And we're talking about friends and discoveries at the Lunar and Planetary Science Conference in Houston just a few days ago. And the first thing, before we go too far, let's define friends. I mean, the thing about science is that it's collaborative globally. And that means,
Yes.
for the most part, it's collaborative on the internet. And I always say, you miss something in this world, in our modern high-tech world, if you don't actually talk to people and feel them breathing next to you and all that stuff. And when you go to these conferences, you do. You meet them. You feel the Sturm and the Drang. You feel the roar of the grease paint and the smell of the crowd. It's different when you're with them personally, isn't it?
Yes, and so is the sense of excitement. There were 1,700 people at this conference in a big hotel conference center, but not as big as our conference center is here or and the other big venues. But this was a big Marriott hotel, and there's a huge lobby area or foyer where people gather. You know, they go out to get coffee, and there's at any one time of those 1,700 people, there must be a couple hundred of them out there, huh?
And the rest are listening to talks. But
yeah, they do go listen to talks, but they're
you go
talking
in and out.
to
You may be
Right,
listening. You may come out and schmooze. You may go back and listen.
Well, and some of that schmoozing is things you're working on together,
Yeah.
or working on, if not together, both of you working on them,
Yes.
even if it's
And
not
then
a
you can work
collaboration.
together after you discuss it. Yeah.
But I think there's something about this big gathering with so many people, all interested in maybe different aspects of this space science business, but all interested in it. And everywhere you go, you can talk nerd talk.
including lunch and dinner. They're working lunches and working dinners, and it doesn't stop.
Yeah.
You gotta love that though. If this is what you do, and and it is obviously what you guys do, then this is the joy of having it come alive right there with you.
And it's better to talk to people. We can Skype and we can just do telephone calls, send long emails, but sitting right next to somebody, interacting real fast. I went out to lunch with two guys from France. One's an American in Paris, a guy named Marc Rizuric. Another one is a French geophysicist. And we talked about a paper we're working on, and it was so much easier to decide how we're approaching this problem that we're working on, which is how hot the moon got where and for how long.
So you're actually stepping up your game by having that tete-a-tete with them.
Yeah.
Because you actually improve, your thinking and your plan for action and all that. Go ahead.
Our students practice their talks, of course,
Oh, do they?
before they go.
They bring posters too?
Yeah, well, yes.
Everybody brings posters.
And some of them are giving their 15-minute talks. So they practice at HIGP before they go, and we try to anticipate what questions they're going to get from the audience.
Yeah.
But it's true, you have an international audience. So after they finish their 12 minutes of speaking, then it's open for questions. And people, they're up to the microphones asking questions, and it's a really good back and forth, and it really tests your background knowledge. And it's such a great experience.
Yeah, and it's a validation aspect.
Yeah.
Yes, this is really happening. Yes, there are other people, and I can look at them and touch them and shake their hand and all that stuff, so that I'm not in a vacuum.
Yeah.
This is not purely cerebral. This is real humanity.
You get surprises too. The first time I went to a conference, I had read a lot of papers I was working on meteorites mostly, and there weren't any moon rocks. And and I had read papers by some famous people in the field. And reading it, you build up a mental image of what the guy must look like. Well, it was never right.
No, can't be. Yeah. But when you meet him, the whole thing clarifies, right?
Yeah.
As soon as you put your eyes on him, the whole thing materializes.
Yeah,
in front.
it's funny.
It's fun.
One of the other thing about getting together is that people actually get together and work on not only planning a paper like I was with the French guys, but I met with a student who left here a year ago now, almost a year ago.
With her PhD.
With her PhD, and we have a paper lingering, and so we worked for 3 hours one morning, skipping the sessions, but that was so much more efficient than trying to do it by, we were Skyping. She's in England now, and you got a time difference, but also you could point to things, you make little sketches, you can do all things, and it's just so much better in person.
Yeah.
And we were in a room off a big hallway, and two other people were there doing the same thing. They too are separated by an ocean, and it just makes it so much better to talk in person. And I thought, you confer at a conference, and that's more important than than
Sure.
equally important
Sure,
than listening to the
you
talk.
make a choice. You may want to go in and listen to a speech or a panel, but you also may want to just schmooze. Who
Yeah.
knows what will pop out of that? The thing about it is you cannot do science without these conferences. Am I right? You have to have these conferences to do
Yes,
good science.
I think, and it's part of the sharing of the discoveries too. You share them with your colleagues, and some of the press is there, but it also sharpens your understanding of things so that you can share it with public talks that you give.
Yeah.
Plus our Planetary Science Research Discoveries webpage, where we
Yeah.
write articles about recent discoveries.
We talk to the first authors of those papers, and then we make sure we know what new papers are coming out so we can cover it.
Sure. And the celebrities too. I mean, there must be famous people who've been published a lot, who are known in the community, in the academic community, the scientific community.
Oh, you
all
mean
over.
Jeff Taylor?
Yeah, Jeff Taylor. They probably line up around the block just to say hi.
Oh, they mob me. My hand's just exhausted
Poor guy.
from the
Our
autographs.
hearts go.
Astronauts? No, there's Jeff Taylor here.
You saw him on ThinkTech.
That's right.
Well, let's go take some more pictures and continue our tour around the conference. This is the Lunar and Planetary Science Conference in Houston.
We met up with another astronaut. This is Stanley Love, and he was a postdoc at HIGP. Didn't he postdoc with Klaus? Kyle?
With Klaus, and our whole group, but with Klaus officially,
yeah,
yes.
he's an asteroid researcher turned astronaut. He's been, I think, twice to the space station. Did some, extra vehicle walks, spacewalks.
He wrote a paper. This is interesting what happens spur of the moment. There was a guy up at the space station named Don Pettit. And Pettit loves to do experiments. And so he was playing around with flour or baking soda in a baggie. And Stan Love there was the capsule, the communicator from the Space Center. And Don is showing the thing and saying, look at the way they cluster together. And so, Stan Love says, well, you know, Don, that may be how particles started to get together at the very beginning of the solar system, to start forming clots of dust that get to be bigger and bigger, and then suddenly you have rocks that suddenly have asteroids, suddenly have planets. And so they wrote a paper about this. They photographed it like mad about the initial accretion of dust in the solar nebula.
What an interesting idea.
And it happens because Pettit's curious, Don knew the planetary science problems, and they just got together
That's
on
great.
it.
That's great.
That's great.
Is it well received, that idea of the accretion of dust? Is it well received?
Yeah, it is,
Oh,
and
yeah.
you know, everyone thought that must happen, but no one saw it before. And you know, you can't. If you just pile the dust here, it falls on itself, whereas up there, it's floating around, but they do start sticking together.
Yeah.
Probably because it was in air. They should have pumped out well, I guess that would be hazardous, to pump out the space station.
Maybe.
Yeah, okay. I'm no astronaut, but I think that's dangerous.
Yeah, but you need to spend time with astronauts to do it, right?
Yeah.
Okay, what do we got?
Oh, that's some of us. This is
Posters.
Yep, they're actually all our people. That's Liz Coleman, who is a postdoctoral fellow. She works on the Genesis mission, which is a sample return mission to collect the solar wind. And then there's two students. To her left is Marianne Lemelin and Laura Corley. Laura Corley, by the way, she's getting her PhD here. She was
So they traveled from Hawaii to Houston?
Yeah, all of them, yeah.
Yeah, and the one on the right, it was one of our undergraduate majors too.
Great.
And Miriam Lamelin in the middle is from Canada.
Okay. Eh? So you said solar wind. You said collect solar wind. How do you collect solar wind?
They sent this mission out. They exposed these different metals, other materials, just pointing at the sun for like a year. Then they closed it up, brought it back to the Earth. And so they have measured the isotopic composition of the sun this way, or at least the part that comes out. Mm-hmm. What Liz is working on is looking at how much hydrogen there actually was in per square centimeter per second to try to figure that out with some of the advanced gear that we have in HIGP.
You know, those posters really fascinate me because, you know, this is not the kids at the science fair. By the way, the science fair is happening right now.
Oh, it's happening now.
Today.
That's right. Yeah.
Hawaii
yeah.
State Science Fair, Science and Engineering Fair, at the convention center. You want to go down just to see what
Yeah.
those kids are doing with their posters. But you know, it strikes me that it's not like the kids in the sense that if you're a scientist, you want to walk the aisles. You want to see these posters. You want to have a few words with the people who are going to explain these posters to you, because there might be an idea in there that you need to have, that you want to collaborate on.
Yeah.
Mm-hmm.
Yeah. And they, you know, it's true of our incoming graduate students too. They're not biased by some long-held, cherished belief. And you know, we all have these things, and they may actually, it turns out, might be wrong. And they'll ask some question that you don't know the answer to.
That moves the needle ahead.
That's why all of us who are researchers at UAH love to teach, especially our graduate students, because they're asking fresh questions, and that's how you learn new things yourself.
Yeah, that's great. Keep it fresh.
Yeah.
Okay, let's go to another picture and see. Our tour continues.
Okay, so the one in the middle is Katie, who I worked 3 hours with, finishing up our paper. Katie Robinson, she's at the Open University now. And on the right is Jeff Gillis Davis, who is one of our faculty members. On the left is Hope Ishii, who is also one of our faculty members.
Oh, SOAS was well represented at the conference.
Oh,
then.
yes, yes. In fact, we have famous people.
Jeff Taylor?
That's what I was
Linda
going to
Martell?
say. No.
Well, people who are principal investigators on instruments and very prominent in the running of missions to. In fact, we have a cool picture of one.
Mark Robinson.
Yeah, that's
Hey,
right.
how'd you know that?
There he is.
Oh, there he is. There's Mark Robinson.
He got his PhD.
Got his PhD here.
in Hawaii.
And he's the principal investigator on a camera called the Lunar Reconnaissance Orbiter Camera, LROC.
All right.
And which has two cameras really, and he's just one of the best in this business of not only understanding the science, but understanding how to put it together. And get this, he got a master's in photography and art history.
What
Before
a great
he-
intersection. No
Is
kidding.
this great?
That's beautiful.
And he had an art show on behalf of the mission, but you know, he's like put it together in Tempe or some downtown Phoenix or something where Arizona State University is where he is. And they have a magnificent, you can see it online, it must be great in person, show at the Air and Space Museum in Washington.
Photographs of the
synergy.
moon.
Oh, it's the
Yeah.
synergy is just so, yeah.
Come with all kinds of disciplines and experiences, and all comes together. You wonder where his heart is. Is it in photography or is it in space?
Oh, I think it's the both. It is the merger of them. And he takes these pictures, in fact, picture the first one, which is labeled 01.
What an
There it
odd
is.
way
Look at
of
that.
numbering.
Look at this.
Oh, yes.
It's spectacular.
This is the one, the NASA picture,
Yeah.
right? This is the famous
Yes.
picture.
But it's a new famous picture.
Okay.
There's an old famous picture that when Mark sent this out, there's a lunar listserv where people comment on and let people know about things. When this came out, Jack said that I do have, Jack Schmidt, right, moon guy.
Yeah.
I do have
The
I
astronaut.
still have a bias towards the picture I took of the Earth. And he says things like this, and he's not bragging. He just it's an experience.
It's just reality. That's all.
Yeah, but he said this is beautiful, and this was taken. It's a composite of a large number of pictures.
I have to have a philosophical moment. Let's take a break. That's Jeff Taylor and Linda Martell of HIGP. We're talking about friends and discoveries in research in Manoa. We'll be right back. You'll see.
Aloha, namaskar, and hello. My name is Anu Hittel, and I host a show, Climate Change Beyond Outrage. In it, we go beyond outrage to look at solutions to climate problems facing people, nations, and the world. Join me every Tuesday at 1 o'clock Hawaii Standard Time. See you then.
Aloha, my name is Carl Campagna. I am the host of Think Tech Hawaii's Education Movers, Shakers, and Reformers. You can see our show every Wednesday at noon at 12 p.m. on thinktechhawaii.com, as well as visiting YouTube and finding the link for the show there. The show is also aired on OC16. We look forward to seeing you on the show. We have many wonderful guests, including Joan Husted, Corey Rosenlee, where we talk about the very important issues of education for our keiki. We look forward to seeing you there. Mahalo.
Bingo, we're back. I'm Jay Fidel here on Research in Manoa, my favorite show on Mondays at 1 o'clock rock. Here today with Jeff Taylor and Linda Martell of HIGP in SOWEST at the University of Hawaii. Talking about friends and discoveries at the Lunar and Planetary Science Conference just finished in Houston, and we have pictures for you. Here's another one. Watch this. Boo!
We met up with one of our PhD graduates, Miriam Tellis, who is now at the Carnegie Institute in Washington, D.C., and tell them her news.
Her news is that she's just been offered a faculty position at the University of California, Santa Cruz. So which just kind of shows our graduates are in demand.
Yeah.
I mean, they're smart to begin with, but they're well trained.
Yeah.
I mean, it's not surprising because we are not the biggest planetary group, but we're actually among the biggest, and it really is quite well known. In fact, all of SOS, that's why I came here. SOS was so well known, and it's been recognized now there was a study done by Nature magazine, which is does this kind of thing among other things, and rated it in Earth, or the broadest sense of Earth science and environmental science, the 15th best in the world.
I've seen that, yes.
Yeah. And better than Princeton, MIT, Harvard, and in its ranking. And it ranked it not just by opinion poll among other academics. It was really based on papers published and how they were cited and things like that, real quantitative measures. But that's why I think it came here. It's such a growing intellectual concern that it's wildly successful. And
on a global basis.
Yes, on a global basis. And I think it's because it's here, too, that people collaborate widely. People are open to collaborations because people like Hawaii like the openness and the friendliness. The people who don't like it leave, which is
okay.
It's okay, and they didn't like it. But the ones who like it stay in it. It really is one of the more friendly places. You can hear faculty in other places fight among themselves like mad.
That seems silly. But I mean, you're right. I mean, I've come to this conclusion a long time ago, that Hawaii is a special place for collaboration. We know how to collaborate. And then you put that syllogistically together with the notion that science requires collaboration, that you do better science if you can collaborate.
Yeah.
If you don't have collaborative skills, you're just not going to do as well.
No.
You can't sit in a silo somewhere and do great science, especially on ocean and earth science, especially on planetology.
Big, broad, and everything is connected with each other. You can't understand the surface without knowing something about how the air or the ocean interacts with it.
Yes.
And otherwise you're kidding yourself if you think you can figure it all out.
Yeah.
But requires, but there's so much to know. It really is better to work with other people.
But the point, oh, sorry.
Every single person, I think, well, of course, at this conference is working with other people. No one can do something all by themselves.
But a footnote to all of this is that the public here in Hawaii doesn't know that you're number 15. Doesn't know the quality of the work you do, the quality of your graduates, and your reputation in the scientific community. The public here doesn't know. So we have to keep on having these discussions.
I think we have to keep,
and we have to keep on getting the word out.
A lot of us are not into bragging. It feels like you're tooting your own horn, but you really do have to do some marketing in this to get your message out that we have a good place and we do really great things.
Yeah.
Invite more people to our open houses so they can see what we're doing and meet us.
Yeah.
It's really important. Okay, what we got? Let's continue the tour. I want to get finished with all the photographs before we run out of time.
That was taken at night, so that's why it's not.
That was taken at night there are social events And
That's Patrick.
that's Patrick Gazda, who's at Los Alamos National Lab now. He's a graduate, a recent graduate of a
Another
year
graduate.
ago.
Wow.
And
This is
he
old times
works.
and old friends.
He works on the. Yeah, our picture taking was a little Hawaii-centric. He's working on the Curiosity rover.
What is that? That's Mars?
That's the one on Mars, driving around this crater filled with rocks altered by water on Mars.
Is that the one with Matt Damon behind the wheel?
Yeah.
Okay.
Yeah. In fact, that's Matt Damon. Incredible makeup job. He's wearing a lei because we do host an annual, and the students take care of this, Hawaii party.
Cool.
It's at a bar.
Cool.
And so the only thing that people who come into the party they don't get free drinks. They all get a fake flower lei. So kind of hard to.
Bring 300 or 400 to a flower lei.
You flew them in. Yeah. Oh,
Yeah.
great. Important. Okay, what's this? Who's this?
Well, these are 3 people. Only 2 of them are our graduates.
Okay.
The guy on the left is David Kring. I work with him because he's PI of a project from which we've been getting $90,000 a year.
Mm-hmm.
He gets his picture taken if you give us money.
Fair enough.
And he runs this program really well. And then in the middle is Romy Snyder, when she was with us, who is at the University of Texas, Austin. She runs a lab that is X-ray, does CAT scans of rocks.
Okay. Why not?
So you can
rocks have
see-
feelings too.
They do, and you never know, they may get sick. And so they do CAT scans of them. And you can see what's inside the rock without cutting it up. And the one on the right is Brett DeNevi. She's one of our graduates. She's at Johns Hopkins University Applied Research Lab and is one of the experts on remote sensing of the moon and Mercury.
These are all great schools you're naming. Your
Yeah.
graduates have gone to the best schools, best research facilities in the country.
Yep, they do. It's great.
We're always kind of sad to see them go, but our job is to train them.
Yeah.
And
Yeah.
see
I
them
know.
off.
But they have, they have to go. You can't keep them here forever.
What about Brad and David?
I'm glad you asked.
Funny you should ask.
There they are. Brad's on the left. He's not important because Dave's one of our graduates.
Got it.
And Dave blew it. He works the same place as Brett does, and he is one of the very best remote sensing specialists on the moon and Mercury in the world too. Brad Jolliffe is at Washington University in St. Louis, and he's one of the best geochemists around. And speaking of collaborations, he organized an effort to have people collaborate on remote sensing and sample studies and geophysics, bring it all together. Well, he learned all the remote sensing too from his normal labs-based rock analysis. So he's like his own collaborator. And I mean, it's remarkable how much he knows.
Yeah.
I mean, usually we get a little specialized, but can communicate with someone else. Nah, Jolliffe does. He just actually puts it together. It's very difficult to learn the 2 things, but he's very smart. He's trying to get to be a mission to the moon to return samples, and he's tried twice now, and it was a finalist last time. Lost out to a mission that's going to collect samples from an asteroid.
These are all robotic missions.
Robotic missions.
But he
Nothing
sets
yet.
up the robots.
He sets up
And
the
he gets the
spacecraft. He
product of what
would
they
manage
pick
the
up.
spacecraft and plan it, and it was a big science team.
No astronauts yet.
No. So anyway,
Is that the future, though? You know, we're talking about hands-on and personal and breathing together and
Yeah.
all that, but in the future, it's going to be robots, no?
I think robots will lead the way, but people will follow.
Yeah. Okay.
These guys, that's Paul Lucy on the right. He's one of our distinguished professors, and he's the one who I think he's actually the best remote sensing specialist in the world. And the guy on the left is a guy named Mark Norman, who is from Tennessee, lives in Australia, and he was a postdoctoral fellow here, and I have written some papers with him, and he's a great geochemist. And in fact, he's the executive editor of the prominent geochemical journal. See the guy in the background with a kind of pinkish shirt?
Yeah.
That is the guy who's the director at NASA headquarters of Planetary Science Division. So all the things that go to Jupiter, the moon missions, the Mercury mission, the Dawn mission to 2 asteroids, his organization runs it.
So when you graduate, say from your program, SOS or HIGP, and you're looking around for a job or a place, I mean, are you besieged with offers? Is it hard to find a job?
No, it's hard, yeah.
Yeah, really?
Yeah, and I think all of us who have students and have had them make it our responsibility to help them get jobs. And it's like an ongoing thing too. You know, you may get them help them get a good postdoctoral position where it's a 2-year fellowship, and they can write a lot of papers and they get someplace, but and build up their own credentials. But still, you have to be on the lookout for all of them,
Sure.
and always ready to write letters of recommendation.
Sure.
And because it's like your children.
Sure. I knew you were going to say that. I could feel it. But your CV is an important part of getting the job. Yeah.
Yes.
And if I'm a student and I go, I trundle along with you to the conference in Houston, and I press the flesh with all these guys who run, big operations, that helps me connect for
Yeah.
a job, doesn't it?
Yes.
I mean, are jobs made and are job deals made at this conference?
Yes, and certainly you meet the right people, and so they can put a face to you, and it helps if your advisor is known by.
Yeah.
It really does. Coming from Hawaii makes the difference
Yeah.
from HIGP
Yeah.
and our Department of Geology and Geophysics. It makes a big difference. Probably through in astronomy too,
Yeah.
and all the SOS disciplines. It makes a big difference because you're coming from a place that's recognized to be good.
Right. Right. And you put your principal investigator down, that helps too.
Yeah.
And if he's somebody like Jeff Taylor, it helps a lot.
Yeah, all my students are pretty much unemployed. As a result.
I don't think
That's
so.
a shame. It's really.
Let's take another picture or two while Jeff mulls that over. What do we
That's
got?
Mercury. One of the sessions, maybe for a couple of days, I think they had talks on different geology of Mercury. One of
That's a
these
false color
false
image
color
there.
images.
It's a false color. I
Yeah,
was going
they
to say
just-
it's a beautiful color.
It's a beautiful color. They stretch things.
To bring out those boundaries between the different colors, they just want to see
There are
where
different surface materials.
Otherwise, it's
and-
grayscale and it kind of looks like the moon. Like a lot of people just think it's the moon because it's got all those round craters.
Yeah.
That was a nice topic.
Mercury's a fast planet, though, isn't it?
It goes around fast, but doesn't spin too fast. I mean, it's
Yeah.
the days are kind of long.
So before the Messenger mission, we didn't know a lot about Mercury. You know, this data was brand new.
In fact, we had only imaged a half or less than half on flybys, and the mineralogy was unknown until Mark Robinson, while he's a graduate student here, he went out to, he knew there was this data available that was never used before, but it wasn't clear you could read it from tapes, so he had to find the equipment, which he did, read the tapes, and figured out some things about the composition of the surface,
Interesting. From the
verified
photographs.
by this complicated mission.
Okay. Let's look at Pluto. We can't finish the show without a word about Pluto.
Oh, surely not.
Before, about a year ago or so, before, that was sort of the image we had of Pluto, kind of a white
It's a
fuzzy
space
thing.
telescope picture.
And then the New Horizons mission launched in 2006, and it finally flew by Pluto last year. And we're starting to see some of those new images.
I mean,
Wow.
isn't that amazing? It has
So
these,
yeah,
yeah.
it's an icy
Could
body,
be
but
right
it's,
out there.
it's not just water ice, it's methane,
Methane, it
carbon
could be
dioxide, carbon
mono-
monoxide,
It's
smog.
It's a funny thing. It's out in this place called the Kuiper Belt.
So there's all these small bodies out there.
Okay,
Interesting
we're
stuff.
out of time, you guys. But if you want to know more about Pluto, go to the open house. And,
Yeah, that's a year and a half away, though.
okay, well, study.
Yeah.
File your application to study at SOS at HIGP, the
Yeah.
Hawaii Institute of Geophysics and Planetology. That's Jeff Taylor and Linda Martell. Hope you guys come back soon. We're not done yet. We'll
Fine.
never be done.
Nope,
Yeah.
never.
Thank you so much. Research in Manoa. We're talking about friends and discoveries. What a great topic.
They just, oh, he's on.